Welcome to the testing laboratory. I am your lead tester, and today we are running a full, high-stakes diagnostic on the Cambridge Mathematics AS and A-level syllabus, specifically locking our targeting sensors onto the notoriously tricky 9709 Section 2.3 Trigonometry compound angle formula. We are talking about the heavy hitters today: sine A plus or minus B, cosine A plus or minus B, and tangent A plus or minus B. Now, look around the lab. On the screens behind me, you'll see our real-time myth status bar, a mark volatility grid, and live script analysis. Over on console 1, we've got tester Alex, a student who absolutely believes every single viral 15-second study hack video on the internet, usually resulting in overloading the page with completely irrelevant jargon. And over on console 2 is tester Sam, who writes incredibly fast and thinks using massive, complex-sounding math words somehow compensates for totally ignoring the actual command word of the prompt. We are stepping in to act as your ultimate mythbusters today. We are going to strip away the bad advice, stress test those terrible online study lies directly against the official Cambridge mark scheme, and replace them with bulletproof structural writing strategies straight from the people who actually grade your papers. Let's fire up the primary testing screen and get to work. Now, what's really interesting about this slide, and why the stakes here are so incredibly massive, is this direct quote from a principal examiner report. Look at this. This topic appears in every examination series. You literally cannot hide from compound angles. It is a mathematical inevitability. It's not a drill, it's a guarantee. So rather than relying on generic, unverified revision tips that tester Alex is currently trying to look up on social media, we are going to look right behind the curtain to build a mathematical framework so incredibly strong that no matter what variation of the question Cambridge throws at you, your logic is going to hold up under immense pressure. Here is our lab protocol and strategic roadmap for today's explainer. First, the compound angle challenge. Second, core theoretical principles. Third, earning method marks. Fourth, top 3 examiner traps. And finally, deconstruct, solve, evaluate. Initiating Phase 1, the compound angle challenge. We are going to start with the single biggest hurdle students face when looking at sine, cosine, and tangent compound angles. This is the ultimate diagnostic question. Examiners constantly ask this very question in their official reports, noting that confusion around key terminology is the primary reason the structural physics of an answer just absolutely breaks down. There is a massive viral myth out there that if you just memorize the formula sheet, you're going to be totally fine. But the mark scheme data tells a completely different story. Examiners explicitly state that candidates consistently confuse key terminology. I'm actually looking at tester Alex's terminal right now, and Alex is trying to distribute a trig function like it's a basic algebra bracket, literally writing out that sine of a plus b is the exact same thing as sine a plus sine b. System failure. That is fundamentally incorrect. When you treat advanced math just as a bunch of disconnected symbols to be dumped onto the page, you completely lose the narrative of the problem. If you don't distinguish between the distinct geometric functions of sine, cosine, and tangent in these compound scenarios, your logic fractures from line 1, and the examiner has literally no choice but to penalize you heavily. So the core objective here is completely redefining how we view these equations in the lab. Compound angle formulae aren't just abstract, meaningless symbols you blindly plug numbers into. They are precise mathematical definitions mapping the specific causal relationships for sine A plus or minus B, cosine A plus or minus B, and tangent A plus or minus B. You have to realize these require precise definitions and logical evidence-based reasoning. They're the foundational theoretical architecture of trigonometry. When you expand the sine of A plus B, you are mapping a very specific geometric and algebraic relationship across a coordinate plane. If you don't respect that precise definition from the very beginning of your working, the entire house of cards collapses under examiner stress testing. Moving smoothly into Phase 2, core theoretical principles. This comparison right here brilliantly illustrates the difference between an average candidate and a top-tier, high-scoring candidate. Superficial breadth versus analytical depth. It's time to officially load myth number 1 into the testing chamber. The myth goes like this. If you write more pages and use more ink, you automatically get more marks. Let's look over at tester Sam's diagnostic console. Sam is currently engaged in massive page dumping, just frantically writing down every single unconnected math equation and trig identity they can think of, hoping the examiner gives him a point for sheer effort. But our mark volatility grid is flashing bright red right now. The Cambridge assessment framework strictly prioritizes analytical depth over superficial breadth. If you just write down an unstructured dump of formulas without a clear, logical progression linked directly to the specific command word in the prompt, your working will entirely fail the audit. Examiners want to see logical, step-by-step mathematical reasoning, not a panicked, superficial scattergun approach. So, for the idea that writing more unstructured pages equals more marks, the myth status bar officially says, busted. So, if page dumping doesn't work, what actually does? What is the single most effective way to demonstrate that required analytical depth? Well, the #1 strategy for achieving significantly higher marks, pulled straight from the raw data of the principal examiner reports, is referencing cross-topic connections within the syllabus. You need to be actively welding data from different math principles together. This trigonometry topic absolutely does not exist in a vacuum. A high-tariff compound angle question might require you to dynamically pull in knowledge from integration, or differentiation, or even coordinate geometry. The students who score the absolute highest on the grid are the ones who recognize these cross-topic connections instantly and systematically analyze them. They build an unshakable, heavily reinforced bridge between the compound angle formula and the rest of the mathematical universe. Initiating Phase 3 of our lab audit, earning method marks. Okay, so the crucial point is how we actually execute this analytical depth on the physical page, which brings us to the method mark strategy. This brilliantly illustrates the standardized procedural framework you must use. This is your strict, myth-free sequence. Step 1, identify key elements. Don't just skim the paper. Do a forensic, deep dive extraction of the given data. Step 2, apply relevant principles. This is where your precise, deeply understood definitions of sine, cosine, and tangent compound angles come into play. Step 3, execute analysis with clear working. You have to follow strict conventions here, using proper headings, correct terminology, and appropriate logical formats. Step 4, verify results. Now, looking at our co-op stress testing lab, Alex and Sam are currently debating the structural physics of their writing blocks. Alex desperately wants to use a generic, pre-written introduction template they found on social media, but Sam is finally realizing that without a direct, tailored analytical link back to the specific command word, the entire paragraph structure is going to collapse under our examiner stress testing. They are having to modify their topic sentences live right now to survive the mark scheme parameters. This 4-step sequence is what saves them. It secures your process marks, meaning even if your final numerical calculation slips up by a fraction at the very end, your logical framework proves to the examiner you actually understand the core principles. I really want you to look closely at this chart. Notice how absolutely massive the proportion of method marks is compared to the tiny sliver of final answer marks. There is a hugely viral assumption online that only the final answer matters in a math exam. Consider that myth totally, 100% busted. Showing clear annotation, proper formats, and step-by-step logical processing ensures you capture this massive, highly lucrative chunk of method marks available. You are literally proving to the examiner, beyond a shadow of a doubt, that you understand the internal mechanics of the mathematical engine. If you just write down a magical final answer with absolutely no clear working, you forfeit the vast majority of the points. It's that simple. Your presentation of information must strictly follow standard conventions to harvest these marks. Initiating Phase 4, the top 3 examiner traps. System pause. Warning lights are flashing across the lab. Before we blast away the biggest exam lie of the century on this next screen and show you exactly what actually wins marks, you need to secure your academic defense network right now. Subscribe to Ace the Exams, that's at Ace the Exams right now, and turn on all notifications. No matter if you are tackling Cambridge IGCSE, O-levels, AS, or A-levels, please do not let bad study advice compromise your final results. Okay, alarm cleared, security transmission complete. Let's get back to the diagnostic. Even with a good structure, candidates still fall into massive traps. So, where do most students instantly lose their marks in this topic? Let's stress test the common revision assumptions against the official principal examiner reports to find out exactly where the mathematical logic breaks down in the real world. We've run the numbers, and here is the data matrix of the top 3 fatal errors. Trap 1. Examiners constantly note that students consistently confuse cause and effect. They wildly apply formula backwards or entirely misinterpret how the compound angles interact with each other in a specific quadrant. Trap 2. Forgetting format and presentation. We literally just talked about the sheer power of method marks. If your working is a chaotic mess, if you don't use clear logical annotations bridging one step to the next, the examiner simply cannot award you those systematic processing marks, no matter how smart you are. Trap 3. Answers are not specific to the context given. You might solve an incredibly beautiful, complex equation, but if it doesn't actually answer the specific scenario outlined in the prompt, like finding a specific angle within a highly specific restricted domain, it's completely useless to the examiner. The math must be welded perfectly and seamlessly to the specific context of the question asked. I am projecting a massive, high-priority alert onto the main testing screen for this one. If you take away absolutely anything from this entire explainer today, let it be this explicit examiner alert. Always define your terms before using them in extended responses. Principal examiner reports consistently reveal that candidates confuse key terminology. If you are launching into a massive, multi-page, complex derivation using sin A plus B, make sure your starting parameters are crystal clear on the page. Do not ever assume the examiner just magically knows what you mean or what your variables stand for. Define your terms first, or you automatically forfeit your analytical marks. This isn't a suggestion, it is a non-negotiable rule of mathematical problem solving at the Cambridge level. Initiating our final testing phase. Deconstruct, solve, evaluate. Welcome to the interactive viewer lie detector arena. I am turning the diagnostic console over to you. Top-scoring candidates use this exact deconstruct, solve, evaluate loop to question assumptions and justify their decisions with clear mathematical evidence. Step 1. Deconstruct a given information. Think of this as the data matrix sweep. When you see a highly complex Cambridge source chart or text data layout, you have to extract the single highest-yielding trend instantly. Step 2. Break into logical steps and solve. This is where you spot the fake shortcuts. If you try to use a popular generic online writing template here, you'll immediately locate the exact line where the logic breaks down and marks are forfeited. Step 3. Evaluate for reasonableness and justify. Does your final answer actually make sense within the strict parameters of the trigonometry context? You have to justify your decisions with clear, undeniable mathematical evidence. This evaluative loop proves to the examiner that you aren't just a basic human calculator. You are a high-level analytical mathematician capable of auditing your own work. Let's lock all this data in with a final review of our bulletproof structural strategy, distilling this entire session into 3 universal truths. First, master the terminology distinction. You have to know exactly how and why your compound formulae work on a foundational level. Second, stick strictly to the standardized 4-step sequence for method marks. This is your mark per minute budget rule, ensuring your procedural framework is absolutely flawless and you capture every point possible. Third, always execute the deconstruct, solve, evaluate loop. This is your post-writing quality audit, guaranteeing your analytical depth. Look at the monitors. Alex and Sam have finally patched their responses using this exact high-yield framework, perfectly welding their data to their analysis. The myth status bar is flashing busted for the online shortcuts and confirmed for our structural strategy. To lock this into your own brain, I highly recommend creating your own memory mnemonic using the first letters of these key terms. Practice your past paper questions using this rigorous framework and never ever leave your method marks up to chance again. Now it is your turn to step into the lab. Drop a comment below right now sharing the absolute weirdest study lie or exam hack you've seen online for Cambridge mathematics so we can load it into the system and stress test it next. Before your next revision session, you need to ask yourself a serious question. Are you just blindly memorizing the formula sheet? Or do you truly understand the deeper geometric relationships behind sine, cosine, and tangent? Master the why, and the method marks will naturally follow. Hit that subscribe button for Ace the Exams, click the notification bell for our weekly myth-busting sessions, and I will see you back in the testing laboratory next time.